Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we would be learning about the atmosphere of our Earth. Let us start by understanding what exactly is atmosphere. So this is our dear Earth, and around this Earth we have a blanket or mixture of gases that surround this entire Earth up till certain height. It's not that you have atmosphere till infinity, but atmosphere is limited to a certain height, and it is nothing but mixture of gases in the form of a blanket that is surrounded around our Earth. So as the definition says, atmosphere is the mixture of gases around our entire Earth. Now, when I say mixture of gases, what does it consist of? So, atmosphere is nothing but certain gases, water vapor, and dust particles. This is the composition of our atmosphere. We have gases, and in gases, you have numerous gases. Then you have water vapor. We just know what is water vapor. It is the gaseous form of water. And finally, you have certain dust particles. Now, let us first understand what are gases or what comprises of gases. So your first important gas which we need to know in our atmosphere is carbon dioxide. Now, why have I made two different faces? One is a smiling face and the other one is sad, kind of looks like a devil with horns on its head. Why is that so? Now, carbon dioxide is a gas which is good as well as a bad gas. Now, we all know that anything in excess would be troublesome. So same goes with carbon dioxide. What is the importance of carbon dioxide? Carbon dioxide is a gas that is transparent to the incoming solar radiation. Now when I say incoming solar radiation, उसका मतलब क्या होता है कि solar means sun and radiation means the rays that sun emits. So the incoming sun rays which are there, they can easily pass through carbon dioxide. So let's say that this is our dear Earth and there is carbon dioxide also included in the atmosphere along with other gases and water vapor and dust particles. So as the sun shines brightly upon our Earth and the sun rays fall, when they enter the Earth's atmosphere, they can easily pass through the carbon dioxide that is present in the atmosphere. And hence I say that carbon dioxide is a gas that is transparent to the incoming solar radiation. Now, when this solar radiation falls on the Earth surface, our Earth also radiates back the heat that it receives into the atmosphere, which we would be learning in the next video, of course, the heat budget of the Earth. But as of now, let us understand कि जब sun अपनी तरफ से solar radiations Earth को देता है, so the incoming solar radiation hits the surface of the Earth, and now Earth also gives back the heat that it gets from the sun. So the heat that the sun gives to our Earth gives it back in the form of terrestrial radiation. Now the heat that is given by the Earth is called as solar radiation, and that which is given by the Earth is called as the terrestrial radiation. Now what happens is the heat that is given out by the Earth in the form of terrestrial radiation, उसके लिए you need to keep in mind that carbon dioxide is opaque, meaning carbon dioxide allows the solar radiation to come to Earth, but it not allows the terrestrial radiation to go out of the Earth's atmosphere. Now, what happens due to this? Let us first understand the importance of it, and then let us understand, and then we will understand exactly what happens when things go wrong in this process. So, if at all, carbon dioxide would not be transparent to the solar radiation, or it would have not been opaque to the terrestrial radiation, the Earth wouldn't have been a habitable place to live. क्योंकि हम लोग को solar radiations मिलते हैं, the carbon dioxide allows the solar radiation to pass so that the earth gets warmer and it does not allow again the heat to leave out of the atmosphere. इसकी वजह से there is a habitable atmosphere, there is a habitable temperature that is being maintained on the earth, and hence I, you, and we all, and all other living beings can survive on this earth. This is the importance of carbon dioxide. It actually makes the earth a habitable place to live because of the two important properties. It is transparent to the incoming solar radiation and opaque to the outgoing terrestrial radiation, जिसकी वजह से अर्थ का टेम्परेचर जो है वो एक हैबिटेबल लेवल पे जाके रुकता है. दिस इज द इम्पोर्टेंस ऑफ कार्बन डाइऑक्साइड. बट व्हाट हैपेंस? What if there is large amount of carbon dioxide that has been created, that has been formulated, or that has been accumulated in our atmosphere, which is currently happening due to the burning of fossil fuels or due to the overuse of many other things? You know, the levels of carbon dioxide are increasing in our atmosphere, and because of which now our earth is warming at a very greater rate than it should have been. जो normal level थे उसमें जितना अर्थ को हीट अप होना था उससे ज्यादा अब अर्थ हीट अप हो रही है because of the increasing level of carbon dioxide. Now, since there is loads and loads amount of carbon dioxide that has been getting accumulated in the atmosphere of the earth, that is why nowadays there are heat waves. Nowadays you feel so much of heat around you, and which is nothing but one of the most famous and climatic event. I cannot say it's a climatic event, it's a climatic disaster which we all are going through, and it is called as the global warming. It is called as the greenhouse effect. What is the greenhouse effect? The trapping of the earth's heat in excess due to the excess amount of carbon dioxide that is present on the earth, in the earth's atmosphere, जिसकी वजह से ग्रीन हाउस इफेक्ट की वजह से क्या होता है? ग्लोबल वार्मिंग होता है. सो एक्सेस अमाउंट ऑफ कार्बन डाइऑक्साइड इन द अर्थ्स एटमॉस्फेयर इज कॉजिंग ग्रीन हाउस इफेक्ट, एंड ग्रीन हाउस इफेक्ट इज फर्दर लीडिंग टू राइज इन टेम्परेचर, which in general terms is called as global warming. And we all know the impacts of global warming. The polar ice is melting, the glaciers are melting, because of which there is rise in sea levels, and since there is rise in sea levels, the habitats which are there near the seas and near the oceans are getting destroyed. So it is important that we all try and we all ensure that the carbon dioxide levels are as minimum as possible, so that the temperature is maintained well below the required level. And hence I have made these two faces, meaning it's good. It is good, it's smiling because carbon dioxide makes our earth a habitable place to live. But at the same time, अगर कोई भी चीज हद से ज्यादा बढ़ जाती है, then it of course becomes dangerous like a devil, and hence we are recently facing the problem of greenhouse effect and global warming. One more important gas which is there is O3, which is ozone. Now we all know the ozone gas is important because it absorbs the ultraviolet rays that the sun emits and which are not good for our skin, and it is this ozone gas, or it is this ozone layer, which actually protects the humans from these harmful ultraviolet rays that have been emitted from the sun. So, apart from these two, there are other gases as well in the atmosphere. There are numerous gases. There are, oxides of nitrogen, there are oxides of sulfur, and many other things. But these two are important, and you need to know about them. You need to know their importance. Again, just like carbon dioxide has its own advantages, disadvantages, ozone also has its own advantages, disadvantages, and we would be learning about it in the later videos. Now let's come to the next part, which is water vapor. The other important component of our atmosphere is water vapor. I have written here that there is variability with respect to equator, poles, and altitude. What do we mean by that? First of all, we all know water vapor is nothing but the gaseous form of the water. When water gets heated up, it gets converted from liquid to steam, and that is nothing but the water vapor. Now you need to understand that the maximum solar insolation that has been received by the earth is near the equator. So ये region है जहाँ पे maximum solar insolation earth को मिलता है. When I say solar insolation, it means the heat from the sun. अगर यहाँ पे maximum sun की light गिरती है, it means that this is the region which gets warmer more. The water over here gets warmer more, and hence you would have more water vapor near the equator as compared to the poles. So as you move from the equator to the poles, what happens is the amount of water vapor keeps on decreasing, and it is pretty obvious because here you have direct solar insolation, and as you go from the equator towards the pole, the solar insolation keeps on decreasing. जितना वेपराइजेशन होना चाहिए उतना होता नहीं है, and hence at the poles we have less amount of vapor as compared to that of equator, and that is why there is variability in water vapor at the equator and the poles. What is this altitude? Same, if I am standing at a place and if I am saying कि as the height increases, equator and pole का एक अलग सा relation है. But what is altitude? We all know altitude is nothing but height. So now if I'm standing over here and if I want to say what is the variability of water vapor in terms of the altitude, so as you move on at the higher altitude, the water vapor would keep on decreasing, and this is also pretty obvious because वो एक हद तक ऊपर जा सकता है, but as it goes, some amount of it would dissipate and finally ऊपर किधर तो जाके it would stop and then it wouldn't go ahead because उतना उस पे capacity रहता ही नहीं है. So when you talk about equator and poles, as you move from equator to the poles, the amount of water vapor keeps on decreasing, and also altitude wise also, as you keep on moving higher and higher, the amount of water vapor keeps on decreasing. So that was about water vapor. Now let's move on to dust particles. What are these dust particles? Dust particles are, normally if a volcano erupts, we have ash particles, we have soil particles. So any particle which is solid in nature is nothing but a dust particle. Now these are microscopic in nature, and that is why, or they can be macroscopic also. Sometimes we can see them, if they are big enough we can see them with our naked eyes. Otherwise normally also there are microscopic dust particles always present in the atmosphere of the earth, and they have got their own importance. Now there is one point that you need to keep in mind, और वो ये है कि ये dust particles जो होते हैं, अगर like I have said कि water vapor के लिए ये एक वेरिएबिलिटी फैक्टर है, वैसे ही अगर हम डस्ट पार्टिकल्स के बारे में देखें, as you move, the amount of dust particles in the subtropical and the temperate regions. Now what are the subtropical and temperate regions? We all know that our earth is divided into many regions. The region near the equator is called as the tropic region, okay, just below the tropic of कैंसर एंड अबाउट द ट्रॉपिक ऑफ कैप्रिकॉन, जो इक्वेटर और इन दोनों लाइंस के बीच में रीजन होता है उसको ट्रॉपिक्स बोलते हैं. उसके बाद वाला जो होता है उसको सब ट्रॉपिक बोलते हैं. उसके बाद वाला टेम्परेट होता है. देन यू हैव सब पोलर एंड देन यू हैव द पोलर रीजन. सो ये जो रीजन्स होते हैं, सब ट्रॉपिकल रीजन एंड टेम्परेट रीजन्स, यहाँ पे डस्ट पार्टिकल ज्यादा रहते हैं. नाउ व्हाई ऐसा क्यों होता है? Because this is the region where there is maximum rainfall and the climate over here is very wet, but here इतना rainfall नहीं होता, and the climate in the subtropical and the temperate region is very dry, and in dry regions that the dust particles are more, they can freely move क्योंकि moisture इतना नहीं रहता air में, and that is why the dust particles in the subtropical and temperate regions are more, because the climate over here or the weather over here is dry in nature. Now what is the duty, or you could say the function of these dust particles? They are nothing but hygroscopic particles. What do you mean by hygroscopic particles? Basically ये अगर एक dust particle है, and whenever there is this phenomena of rainfall that is going to occur. यही basically dust particles होते हैं जिनके around the water vapor is going to condense and they are going to form water droplets. ठीक है, तो ये इंपॉर्टेंस होता है डस्ट पार्टिकल्स का. सो इस पर्टिकुलर पार्ट ऑफ द वीडियो में व्हाट वी हैव सीन इज कि अर्थ होता है, अर्थ के आजू बाजू में एक एटमॉस्फेयर होता है, and atmosphere is nothing but the mixture of gases, a blanket that is there around the earth. It exists up till certain height only. It is made up of different gases, water vapor and dust particles. Gases are many, but we have just learned about two, carbon dioxide and ozone. We saw their importance, their advantages, what happens if they go in excess. Then we saw water vapor and its variability across the equator and polar and altitude wise also. And then we saw कि dust particles exactly होते क्या है, ट्रॉपिकल, सब ट्रॉपिकल एंड टेम्परेट रीजन में वो कितने अमाउंट में प्रेजेंट होते हैं एंड व्हाट इज देयर फंक्शन. नाउ लेट्स मूव ऑन टू द नेक्स्ट पार्ट which is the structure of the atmosphere. Now, you know, our body has got a structure. Your house has got a structure. Your school has got a structure. Your college has got a structure. So everything is structurally placed, right? So likewise, even our atmosphere is something which is structured. So यहाँ पे भी एक proper structure follow किया जाता है and we are going to see what is that structure. Now our atmosphere is divided into different layers and these are those layers. The first layer or the layer which is closest to the earth's surface is the troposphere. And it is varying with the height, like 8 to 18 kilometers की height है. मतलब अर्थ के सरफेस से 8 किलोमीटर्स तक एंड अर्थ के सरफेस से 18 किलोमीटर्स तक हम लोग कह सकते हैं कि whatever atmospheric layer exists, it is nothing but the troposphere. Now, why do I have 8 and 18 kilometers? You need to keep in mind that again, the same logic which we have used here for water vapor, that same logic goes over here. That near the equator, the width of the troposphere is more because there is more evaporation. Water vapor can travel to a great height, but that is not the case with the poles, and hence we can say कि since there is maximum solar insolation at the equator, that is why the height of the troposphere near the equator is more, and hence we can say कि equator के पास उसकी height 18 रहेगी, whereas poles के पास उसकी height 8 रहेगी. And what is the reason? Because the reason is only solar insolation. जो हमारा सोलर रेडिएशंस जो होते हैं, सोलर इंसुलेशंस जो होते हैं, वो इक्वेटर के पास मैक्सिमम पहुंचते हैं, एंड सिंस दे रीच द इक्वेटर मैक्सिमम, दैट इज व्हाई द हाइट ऑफ ट्रोपोस्फियर एट द इक्वेटर इज मोर एज कंपेयर टू दैट ऑफ द पोल्स. सो 8 to 18 is the range of troposphere. Now, troposphere is something we also are going to learn different phenomena in each of these layers. Like I'll tell you, normally we know that as you move upwards, जैसे जैसे you just try to remember a mountain. As you climb up the mountain, as you move up and up and up, the temperature goes on decreasing, right? At the foothills, you might feel little warmer, but as you go up, you climb upwards, you try to feel colder, right? So same goes over here. Troposphere में, as the height increases, the temperature is going to decrease. Now, this is not the phenomena that takes place in every layer of the atmosphere. This doesn't happen. But in troposphere, this phenomena where height increases and temperature decreases is called as the normal lapse rate. What is this normal lapse rate? Normal lapse rate का मतलब क्या होता है कि as your temperature is going to as your height is going to increase, your temperature is going to decrease. और वो कैसे decrease होता है? For every 1 kilometer, there would be a decrease of 6.5 degrees Celsius, or for 165 meters, the temperature would decrease by 1 degree Celsius. This is the normal lapse rate. So if anybody asks you what is the normal lapse rate of Earth's atmosphere, इसका मतलब क्या है? That as you move up and up and up, the temperature is going to decrease by 6.5 degrees Celsius for every 1 kilometers and 1 degree Celsius for every 165 meters. This is the normal lapse rate. So troposphere की height is between 8 to 18 kilometers. It is following the normal lapse rate, wherein the temperature decreases by 6.5 degrees Celsius for every 1 kilometers or by 1 degree Celsius for every 165 meters. And as I told you, normal lapse rate matlab as your height increases, the temperature is going to decrease. This is what happens in normal cases. Now let's move on to the next layer, which is the stratosphere. Stratosphere की height है surface से 50 kilometers तक. From the surface up till 50 kilometers जो है वो stratosphere है. Now I have written 3 words over here and you need to know about these 3 words. First is O3. As we know, what is O3? O3 is nothing but ozone. हमारा ozone layer is something that has been present in the stratosphere. So stratosphere is very important. It is strategically important layer. So keep in mind कि stratosphere में सबसे पहले strat O, उसमें O है तो ozone layer है. Ozone is very important for us. So what happens is, this is the layer which protects us from harmful UV radiations. The ultraviolet radiations that the sun emits, इसी layer में आके उसको absorb करते हैं. But now what happens? You only imagine कि यहाँ पे ozone layer है, यहाँ पे ultraviolet rays है. Ultraviolet rays have great energy. वो सारे इधर आके absorb हो जाते हैं. So all the ultraviolet rays are going to come and they are going to get absorbed in this layer, only in this layer of the atmosphere, because of the presence of the ozone layer. So now what would happen here? Will the temperature decrease as the height will increase? That is not the case. Now since there is ozone layer present here, that is why as you move up and up, the temperature is also going to move up and up. So as your height increases, the temperature also increases, and this phenomena is called as the temperature inversion. What do you mean by temperature inversion? Normal cases में as your height increases, temperature decreases, but इधर उल्टा होता है. As your height is going to increase, the temperature is also going to increase. And why is this happening over here? That is because of the presence of the ozone layer. Also, there is something called as polar stratospheric clouds. Now, this is also linked to O3. Now, if there are polar stratospheric clouds present in this layer of stratosphere, then that's a trouble for all of us. These are the clouds which are responsible for the depletion of ozone layer. So ये clouds होते हैं which are responsible for the depletion of the ozone layer, and that is why people, or we can say that it is made sure that these clouds are not present over here. Of course, the formation of these clouds is due to human and anthropogenic activities only. It is we who cause more and more pollution and global warming, because of which there is presence of polar stratospheric clouds. The entire mechanism behind it would be told to you later. धीरे-धीरे you will understand as we move ahead. But as of now, you need to keep in mind कि stratosphere is that layer of the atmosphere जहाँ पे ozone present होता है, ozone layer present होता है, and because of this ozone layer present over here, it shows the phenomena of temperature inversion, and this ozone layer is depleted due to the presence of polar stratospheric clouds which are present in the stratosphere. Now let's move on to the third layer, which is the mesosphere. Now the range or the height of the mesosphere is from 50 to 80 kilometers. मतलब अगर height की बात करें, it is लगभग 30 kilometers. Now here, this is the coldest layer of the earth. Okay, ये layer of the atmosphere, sorry. ये earth के पास था तो ये normal था. यहाँ पे ozone है, that is why it has been heated up. Here there is nothing that's present. So this is the layer which is very, very cold out of all the layers. Now here normal thing happens. Apna, as you move up, the temperature is going to decrease more and more. As you climb up and up in this particular layer, the temperature is going to decrease more and more. Now here the clouds that are present, they are called as mesospheric clouds, and they are not problematic. It is okay. This layer is having mesospheric cloud. It's okay. These clouds are noctilucent, meaning कि they are luminous or they shine during night time. And it is, we all know what are meteors. Meteors, when they enter the earth's atmosphere, and so let's say ki if a meteor is entering the earth's atmosphere, the time that it enters this particular layer, that is mesosphere, it burns up. So if at all the question comes that meteors burns in which layer of the atmosphere, it is the mesosphere. So mesosphere is the layer which is the coldest layer. It has got the mesospheric clouds which are noctilucent in nature, that is, they are luminous during night time, and meteors burn in this layer. Now let us finally move to the last layer, which is the thermosphere. Now thermosphere की जो height है, it is from 80 to 400 kilometers. This is the last layer, so this would be the layer that would be more closer to the sun. अभी यहाँ पे भी वही लॉजिक लगा, if this is the layer which is closest to the sun, will this layer have normal lapse rate or temperature inversion? So this layer is going to have temperature inversion because this layer is closest to the sun. So as you move ahead or as you move upwards, the temperature is also going to increase. यहाँ पे normal lapse rate नहीं काम करता. The reason is it is closer to the sun. So here we can see the phenomena of TI, means temperature inversion. That as your height is going to increase, the temperature is also going to increase. I have written something called as Kármán line. What is this Kármán line? This is the line which separates the Earth's atmosphere and space. It's a boundary between Earth का atmosphere and the space. ये कहाँ पे होती है? Exactly at 100 kilometers. 100 किलोमीटर्स पे, जहां पे भी 100 किलोमीटर होता है, लाइक ये तो यहाँ तक 80 किलोमीटर्स होता है, यहाँ से 20 किलोमीटर्स, और इन द थर्मोस्फियर, okay, there would be one line at 20 kilometer, and this is nothing but the Kármán line, and this is your earth का atmosphere, और यहाँ से जो शुरू होता है, that is nothing but your space. So Kármán line is the boundary between your earth's atmosphere and the space. It starts exactly at 100 kilometers from the surface of the earth. यहाँ से आपका space शुरू होता है. So your satellites, your rockets and everything, you know, are being sent over here. Now inside this thermosphere there is one more layer which is nothing but the ionosphere, and it has got its own importance. ये जो ionosphere है, ये बेसिकली इम्पॉर्टेंट है फॉर रेडियो वेव कम्युनिकेशंस. इस आइनोस्फीयर में बहुत सारे आयंस है, पॉजिटिव एंड नेगेटिव आयंस आर प्रेजेंट विच आर रिस्पॉन्सिबल फॉर द रेडियो वेव कम्युनिकेशंस. सो आपके मोबाइल सिग्नल्स, जो सैटेलाइट से मैसेजेस आते हैं, जो डीटीएच कनेक्शंस है आपके हाउस में, ऑल दीज गेट सिग्नल्स फ्रॉम द आइनोस्फीयर. एंड बियॉन्ड द थर्मोस्फीयर वी हैव द एक्सोस्फीयर. ठीक है, so exosphere is nothing but things that are beyond the thermosphere. So this is the structure of our Earth's atmosphere. To sum it up all, we started with the troposphere first, which is 8 to 18 kilometers. It follows the normal lapse rate, that is, at every 1 kilometer the temperature decreases by 6.5 degrees Celsius, or for every 165 meters the temperature is going to decrease by 1 degree Celsius. Also, at the equator, the height is more as compared to that of poles. Then comes the stratosphere, surface से 50 kilometers तक. यहाँ पे stratosphere, so उसमें O है, O3 is present, ozone layer is present. ओजोन लेयर है, इसका मतलब यहाँ पे टेम्परेचर इन्वर्जन होता है, और अगर पोलर स्ट्रेटोस्फेरिक क्लाउड्स है तो ओजोन के लिए वो खतरा हो सकते हैं. एंड देन कम्स अपना मेसोस्फियर. मेसोस्फियर इज द कोल्डेस्ट लेयर. हियर यू हैव द नॉक्टिल्यूसेंट क्लाउड्स व्हिच आर द मेसोस्फेरिक क्लाउड्स एंड meteors burn over here. Then you have thermosphere, which is closest to the sun, and hence it shows temperature inversion. कार्बन लाइन यहाँ पे 100 किलोमीटर्स पे है, विच इज नथिंग बट द बाउंड्री बिटवीन द स्पेस एंड द अर्थ्स एटमॉस्फेयर. और इसी थर्मोस्फेयर में एक और चीज है विच इज आइनोस्फियर, रिस्पॉन्सिबल फॉर द रेडियो वेव कम्युनिकेशन. And finally, beyond the thermosphere, we have exosphere. So I hope students, you have understood what has been taught in today's video. If you have any doubt, please post your comments and reach out to me. I will surely clear your doubts. Thank you so much and see you soon in the next video.